Good day everyone. Welcome to our session for today. So we are going to discuss solvable groups of trigonometric integrals for this session. So there are solvable groups of trigonometric integrals. We have group 1, integrals of the form integral of sine to the m u times cosine to the n u du. The other one is integral of sine to the m u times du, and the other one is the integral of cosine to the n u du. Okay, so there are times that you are given this form of the integrals. So to solve those integrals, we are going to follow some procedure or some rules. Okay, so here the condition is that m and or n are positive integers. So you can use the following rules regarding this form of integrals if it will satisfy this condition that m and or n are positive integers. And we have to deal with three cases here. One is when m is odd, factor out sine u du and then change the remaining sign into cosine using the identity sine squared u equal to 1 minus sine squared u equal to 1 minus cosine squared u, and then simplify the result and integrate using the appropriate formulas. Okay, so to give you an idea, so we have here an example. Example 1, integral of sine cube x times cosine squared x dx. So if you look at the given, our m here, m is the exponent of sine, n is the exponent of cosine. So you see here n equal to 3. So the condition is that when m is odd, so this is case 1, right? When n is odd, then factor out sine u du and then change the remaining sign into cosine using this identity. Sine squared u equal to 1 minus cosine squared u. Then simplify and integrate using appropriate formulas. Okay, so we will solve this problem. So we're given for example, so we have the integral of sine cube x times cosine squared x dx. Okay, so we are going to break this sine cube x into two parts so that we can factor out sine u du, because the rule here for case 1, okay, so we have to factor out sine u du or sine x dx, but we don't have sine x dx yet from the given, so we have to break this sine cube. So integral of, we can rewrite this as sine squared x times sine x, then times cosine squared x dx. Okay, then it says that change the remaining sign into cosine. So it says, class, that for this case, when m is equal to 3, we have to factor out sine u du. Okay, so for case 1, so this is the summary, class, for case 1. So factor out. So number 1, we factor out we factor out sine u du, no? From the rule is sine u du, sine u du. Okay, then after that you have to change. So the second step is to change, no? Change. So we have to change sine to cosine. All right, change sine to cosine and then use the identity. So we have to, so to change it, we have to use the identity sine squared u equal to 1 minus cosine squared u. Then number 4, we have to simplify and integrate using appropriate formulas or formula. So simplify, then integrate. So I'm just summarizing it, class. No, using appropriate formulas. Okay, so from this result and following these rules for case 1, so we have to rearrange. So we can rewrite this as integral of sine squared x, then we write cosine squared x first before this one, then sine x dx. So the rule says that we have to factor out sine u du. So in this case, we have here sine x dx. Okay? Then after that, so we have to use the identity. Okay, so using the identity sine squared u equal to 1 minus cosine squared u du, so that we can change sine to cosine. Okay, so here we can rewrite this as instead of sine squared x, so we have to write 1 minus cosine squared x, then times times cosine squared x times sine x dx. Alright, so that's the result. Then after that, we have to distribute. Now we have two terms here. We have first term, second term is cosine squared x. Then we have here the multiplier, so we can multiply its term. Multiply its term by this cosine squared x sine x dx. Okay, so we can do like this. So the result now is integral of, so we have 1 multiplied by this, so we have cosine squared x sine x dx. Okay, then we multiply this and this one, so this is minus, so this is also minus. Then we also distribute this integral symbol or integral sign. Okay, so we have cosine squared x times cosine squared x is equal to cosine to the 4th x, then times sine x dx. Alright, then from here we can say that we can use the power formula. So we can let n here equal to 2 and our n plus 1 is equal to 3. Okay, our n here is equal to 4, then our n plus 1 is equal to 5. Then from this first term, we can let u equal to cosine x. So if our u is equal to cosine x, then we can solve for du over dx, which is equal to sine, or this is minus, no? From the differential calculus formula. So this is minus. So this is minus sine x. Then solving for du, so we have du equal to minus sine x dx. And if you look at our given here, we have sine x dx, this part here, sine x dx. So if we let cosine x as our u, so we have to replace this in terms of du. But we have here sine x dx, but negative. And we have here positive. So to get the positive of it, so we have to multiply both sides by negative 1. Okay, or divide both sides by negative 1. So when we divide both sides, so divide both sides by negative 1. So when we divide both sides by negative 1, so this becomes negative du equal to positive sine x dx. Okay, so similarly for this part here, we can also let u equal to cosine x, and derivative of u with respect to x is equal to minus sine x, and solving for du, so this is minus sine x dx. And similarly, since we need positive sine x dx, so we have to divide both sides. Divide both sides by, I'll just abbreviate this class. Divide, b means both, s sides, so divide both sides by negative 1. So this becomes negative du equal to positive sine x dx. Okay? Then after that, let's substitute. We have from here integral of, we let our cosine u equal to our cosine x equal to u. So therefore we can write this as u, then the power or exponent is 2. Then we have here sine x dx. Our sine x dx is equal to this one, minus du. Okay? So our sine x dx is equal to this. This is negative du. So substituting, so this is minus du. Okay? Then minus the integral of, we have same here, we have cosine x as our u, so we have u, then the exponent here is equal to 4. Okay, so power 4. Then again, this part here, sine x dx is equal to minus du. Right, this one. So substituting, so times minus du, or we can write this as minus, then integral of u squared du, then minus, we have minus and then minus, we have minus, so this will be plus. Okay, so plus integral of u to the 4th power times du. And using the power formula, so our power formula is you have integral of u to the n du equal to u to the n plus 1 divided by n plus 1 plus c. Okay, so we have to make use of that formula. So I will continue it here on the right side. Okay, so our result here, I will just rewrite it, class. So we have the negative integral of u squared du, then plus, sorry, so we have equal to negative of the integral of u squared du. I'm just rewriting it. This one, I'm just rewriting it. Then plus integral of u to the 4th power du. Then applying the formula, so we have minus u cubed over 3, because that is n plus 1, right? 2 plus 1 is 3. Then we have plus u to the 5th power divided by 5. Then plus c. Okay? Then substituting, so we have minus our u. So our u is equal to cosine x, right? So we have u here. We have u here that is equal to cosine x. And same here. So substituting, so we have u, which is cosine x, and raised to the power 3 divided by 3, then plus cosine x raised to the power 5, then divided by 5 plus c. Or we can rewrite this as minus 1/3 cosine cube x plus 1/5 cosine to the 5th power x, then plus c. Okay, so this is our final answer. Or you can rearrange this, class. You can write the positive term first. So you have 1/5 cosine to the 5th power of x, then minus 1/3 cosine cube x plus c. So either of these two answer. So this is our final answer, class. So this is already correct. This one is correct. Okay, so that's all. I hope you're able to follow the discussion, class. Thank you very much, and see you in our next video. Bye.